So this is part two of the series on improper integrals. So I'm going to start right off with question two. So please do refer back to part one just for you to follow what I was doing. So here, if one have to look at this integral from 0 to 1 of x raised to the power of negative a half, which is actually the curve. So say for example, this is our y. This obviously here is our y value. So that means y equals to x raised to the power of a negative a half, which is y equals to um, 1 over 1 over root x. So if I was to sketch this graph, let me just explain that. So I'm going to use the software GeoGebra, and this is nothing but y equals to, so it's y equals to 1 over x, and that should be raised to the power of a half, which is the same as 0.5. So that is the function, and that's how that function is. If you were to look at, let me just label the function. So let's just go to the settings, and it will have the name and value so you can see the function. Okay, so this is our function here. And what you'll realize is what we're actually asked to do here when we are asked to integrate this is we need to find the area under the graph. So it is basically the area under the graph here. But here's the thing though, this particular value of the y-axis, which is the line x equals to 0, this is an asymptote, which means this function gets closer and closer and never actually cuts there. And it makes sense because x cannot equal to 0. Okay, so if that is the case, before I continue with that graph, and I want you to understand that concept from what I was just saying, the function will not be defined. You say the function is not defined if not defined when x equals to 0, then it's not defined. Therefore, what you're going to do is we're going to make the lower limit of the integrals, or the lower of integration, the lower limit of integration, so the lower one, you're going to make that to be a t. Okay, so what we're going to have is going to have 1 and the t over here with 1, and this is obviously x raised to the power of negative a half with respect to x. So I'm going to come back to that. I just want to go back to my curve. Right, so we're basically looking for that area. Now if I was to integrate, and since I know that x cannot equals to 0, so I'm just going to say integral, or integral. Perhaps I'm going to choose this one that gives me the options of the function as well as a start value and an end value. So the function is f, from what I have over there, and I cannot start from 0. You see that if I put 0 as a starting point, I'm implying that this graph is going to cut it's going to cut the the y-axis, but it's not possible. All right, and it's going to end, say, at 1. You see that it says is undefined. All right, so let me go back and say, okay, let's start at something very, very small. Let's say 0 0.00001 perhaps. Can you see that? And if I have to have, maybe I can put another 0. You can see what happens to the area. The area gets to 2. So put another 0. You understand that? No matter how many zeros I continue putting from this case, then you see that the area there tends to 2. So the area under the graph will be 2. And therefore that limit exists. I mean that this integral, it exists in terms of being convergent from 0, but 0 to 1. So that area there will be 2. And this is exactly what we are trying to show you over there. Okay, that does the integral exist? Yes. If it does exist, does it then converge? Okay, so I can just bring back, because I also have the graph over here, so it can just be a reference point so you can see exactly what I'm referring to. So our objective is to find that area, which is 2. because it does exist. All right, so let's go ahead then and let's integrate. So I hope you know that, well, you integrate by adding 1 to the power. So if you're adding 1 to negative a half, that gives you a half. You divide that by a half. Okay, so our limits is from t to 1. So obviously that's going to give us, now that is 2. Now here's the thing, and you should make very sure that you do not make a mistake. Dividing by half is the same as multiplying by 2. So it's 2x raised to the power of a half from t to 1, which you can just go ahead and write as 2 root x, because that's what power of a half means basically, from t to 1. Of course, let me just write it like this, then it's much better. So now I'm going to substitute in my limits, starting with the first one. So it's going to be 2 root 1, which is just equal to 2, minus 2 root t. So I'm going to have 2 root t. Okay, so what did we say? The function is not defined when x is equal to 0. So we are not going to have as t tends to infinity, but as rather as t now tends to 0. What do you have? You have got minus 2 times that. You're going to get the value of 0. So therefore, the integral from 0 to 1 of x raised to the power of negative a half with respect to x is then equal to that 2 minus 0, which is equal to 2, as I have indicated to you over here. So now you can conclude now and say that means, because the question was asking, do the integral, do the following integrals that I'm going to do, does it exist? That means ultimately, does it converge? So my conclusion here henceforth will be, the conclusion here would be, hence the limit exists and is finite. That means it's some value that you can get. The integral, well, you don't have to write exactly what I write. You can just, as long as you deduce anything that makes that sort of answers the question. The integral converges, and the value of the integral is 2. All right. Okay. That's the one that I did. So I'm not going to do graphs for all of them. I'm just going to work from that. You can always use that first one as a sort of indicator. Okay. In this particular case, this value, the function will not be defined if this value, one of the things you must remember is the denominator of any fraction cannot equal to 0. The square root of 0 is equal to 0. So what I now am looking at, I'm going to say, okay, wait a minute. 4 minus x, the stuff under the square root, if I let it equal to 0, I want to see what should the value of x not be. X cannot equal to 4, because the moment you plug in 4 over here, you're going to get 0, and then you have a scenario of 1 over 0, which makes it undefined. Okay, undefined. All right, so that is the case then. So when I come to and I'll write as the function does not is not defined when x equals to 4. Therefore, I'm going to make the upper limit where I have a 4. So my upper limit now here, my upper limit, I'm going to let it be replaced by a t. So that means I'm going to have from 0, integrating from 0 up to t now. And then I just go ahead and write this as 4 minus x. This is raised to the power of negative a half with respect to x. It's just easier for me to do that. And I'll obviously revert back towards the end. Okay, let's now integrate. And again, remember the rule when you are integrating. You have the rule ax plus b all raised to the power of n. So you definitely have to remember this rule where you have 1 over a multiplied by ax plus b, and you have n plus 1 over here, and you have n plus 1. Okay, so no need for the constant because we have got limits here. Right, so in this case, it's going to be negative. I'm going to have 1 over -1 times 4 minus x, adding 1 there, that makes it just a half, okay? And then you're going to divide there also by a half. And obviously this is from 0 up to t. So let's just clean that stuff inside, and just for us to get our thing a little bit in the simplest form. So you have got a half here, which is when you divide by half is the same as multiplying by 2, and then you have a -1 here. So what you're going to have is you're going to have -2, and then inside the bracket you are going to have 4 minus x raised to the power of a half, and obviously from 0 to t. Of course, let me just go ahead and substitute in my values. So I have -2, 4 minus t raised to the power of a half, minus -2, and then I have 4 minus 0, and this is also raised to the power of a half. Okay, right. So the first part here, well, I can put it as -2. This is the square root of 4 minus t. Well, of course, here I'm going to have a plus now, okay? And if you do the stuff inside, 4 minus 0 is nothing but 4. The square root of 4 is 2. So this is 2 times 2, which is giving me a 4 over there. So this stuff in here cleans up nicely to a 4. Of course, don't be afraid to look at your calculator. So I'm just going to take the stuff inside here. So I'm going to take, I have a negative and negative. There's my positive here. So I've got 2 in bracket. I've got 4. Obviously, minus 0 is just 4. And if you raise that to power of a half, is the same as raise or taking the square root. It's just going to be equal to 4. Okay. All right. So that is what you are now getting. So again, you are not going to say as t tends to infinity, but rather as t tends to 4, what the function was not defined for. Then I have -2 root 4 minus t will get to -2 root 4 minus 4. Well, this is just going to give you 0. Okay, square root of 0 is 0 times that is 0. So what does it imply? It implies that, and this is where I'm going to bring in my deduction. Therefore, the integral of 0 to 4 of 1 all over root 4 minus x with respect to x is equal to 0 plus 4, because this stuff here gives you 0, which is just equal to 4. And now you can go ahead and you can do the deduction. You will say hence the limit exists and is finite. The integral converges, and the value of the integral is 4. Okay, right, let's get to the next one, part C. Again, this is also something that you need to remember. The function does not exist when x is equal to 0. Okay, the function is undefined for x equals to 0, because you may not divide by 0 for x equals to 0. So I'm going to write my lower limit, the integral with a lower limit of t. So that means this is what I'm going to have. I'm going to have the integral of t now to 9 of that stuff 12x raised to the power. Now here's what you must also remember. The square root of x raised to the power of that is the same as x raised to the power of 5 over 2. Okay, and since it was under, it becomes negative, so it's negative 5 over 2 with respect to x. Okay, please just make sure that your algebra is sound. So let me then integrate. That is going to be 12 x. If you add 1 here, that's going to give you negative 5 plus 1 is the same as negative 3 over 2. That's negative 3 over 2. So negative 3 over 2 from t to 9. Of course, 12 divided by negative 3. If this stuff confuses you, that is like 24 divided by negative 3, negative 8. Just use a calculator. You say 12 divided by negative 1.5 or negative 3 over 2. Of course, you're going to get negative 8 as an answer. Okay, so do not make a mistake. So that's negative 8. Then it's going to be x raised to the power of negative 3 halves. And let me just scroll up here. So that is again from 9 to t. Of course, this can be written as negative 8 over the square root of x cubed. I'm going to go back and write it like that, from t to 9. So now I'll just substitute in the limits. So that means I'm going to have negative 8 over the square root of 9 cubed. By the way, this is negative. The square root of 9 is 3. 3 cubed is 27. So this is negative 8 over 27. That's what this is going to be. Minus negative 8 over the square root of t cubed. Of course, this becomes then a positive because of these two conditions here. 8 over the square root of t cubed. Okay, now what do we know? As the function is undefined, as x equals to 0, so we then say st tends to not, then here you are going to realize that you have this part here, the 8 over t cubed becomes like 8 over 0, which in our language you realize this is undefined. So if it's undefined, then you can go ahead and say, wait a minute, the integral from 0 to 9 of 12 over the root of x raised to the power 5 with respect to x is infinite. Okay, is infinite. And because it's infinite, we then say, hence the improper integral is infinite, and therefore it diverges. Hence the improper integral is infinite, and therefore it diverges. Okay, right, we have got d over here. So I have got right, you can always pause the video. This is going to be the last part for part 2. So I'm going to have the same condition here. The function will not exist. The function will be undefined if x is equal to 0. Then the lower limit here, we're going to make it to t. So we're going to have t here and 25 over here. And obviously, this is x raised to the power of a half plus x raised to the power of negative 2. I'm just writing it in this way so that it can be easier for me to integrate. And I'm going to integrate them separately. So I'm going to add 1. That is going to be x raised to the power of 3 over 2 now, and divide by 3 over 2. And this is going to be, obviously, if you add 1, that gives you negative 1. So it's going to be, let me just write plus. So this is x raised to the power of negative 1. And then you divide by negative 1. Of course, from t to 25. And again, you can just clean up this stuff inside here. That is going to be 2 over 3. So x raised to the power of 3 over 2. Okay. And this other one becomes a minus here because it's a positive and a negative, minus 1 over x. and that is from t to 25. Okay, right, so it's rather a horrible value if I have to input the stuff myself. So I'm going to substitute my upper limit, so that is 2 over 3, the upper limit being 25 raised to that power of here minus 1 over 25. That is fine for that part. Minus, so I'm going to have 3 over 2, and then obviously that is t raised to the power of 3 over 2, and minus 1 over t. Okay, so now I'm going to have, if I was to continue that, okay, I can leave it there rather, but maybe the first part we just clean it up with the calculator, and you can do that if you want to. This is the square root of 25, which is 5. 5 cubed is 125 times 2, that's 250 upon 3. So this is 250 over 3 minus 1 over 25. Okay, you can use your calculator. All right, I'm just going to leave it like that. Minus, so I'm going to leave this as 3 root t cubed. That's another way to write it, upon 2 minus 1 minus 1 over t. Minus 1 over t. Okay, minus 1 over t. All right, now this is a rather interesting story over here. So of course you can go ahead and say as t tends to 0, as t tends to 0, because 0 was when the function is undefined, you would realize that if you were to substitute it over here, you are going to have, let me just take the parts that have got the t's, the square root of that over 2 minus 1 over t, which is the same as 3 root. So this is fine over here, but here is the problem. You get 0 here, and if that is the condition, this little part here becomes undefined because you may not divide by 0. So this whole thing is going to be undefined. Therefore, if that is the case, the integral does not exist. So you're going to say, therefore, the integral from 0 to 25 of, I had x raised to the power of a half plus 1 over x squared with respect to x, we say is undefined. Is undefined. So the integral does not exist. It diverges. Okay, so this is the end of part 2. Stand by for part 3.